Dentistry Mathematics by John Cruz. Background. Dentistry involves many mathematical applications from dosage calculations needed for local anesthesia over body measurements that to a formula needed for humans and other animals. Black classification formula and determinate dental arch curves and normal ugliness. A few figures could be Crawford L. Long for discovering the use of ether anesthesia and Dr. G.V. Black, who helped fund the 6 classes of lesions and a 3 and 4 number system on what instruments should be used on the dental operation. Brief history of anesthesia. For most years of humanity, anesthesia was never used when it came to performing dental and surgical operations. Therefore, it either resulted in a very painful operation or a more drastic method, such as using alcohol, which intoxicated patients. The first person that used anesthesia during surgical operations was Crawford W. Long, who was an American physician that used ether anesthesia for surgery in 1842 to remove a tumor. It then became famous in the town of 1846, where dentist and physician William T.G. Moulton published his work of performing ether anesthesia to remove a tumor from the person's neck. Today, anesthesia is used in many forms of dentistry and surgical operation. The sources listed below. Crawford W. Long and William T.G. Moulton. Brief history of both of them. Crawford W. Long was born on November 1st, 1815 in Dansville, Georgia, USA. He pursued a career in medicine to practice as a physician. After graduating, he began his medical practice where he eventually experimented with ether anesthesia. However, he did not publish his findings and work since he was unsure about his potential. He finally decided to publish his work in 1849 after realizing how much recognition Moulton got. He titled it An Account of the First Use of Sulfuric Ether by Inhalation as an Anesthetic in Surgical Operation. William T.G. Moulton was born on August 9, 1819 in Charlton, Massachusetts. He studied dentistry at Harvard Medical School, and then he pursued self-education in the study of chemicals, which eventually led to the idea of using ether as a form of anesthesia. He demonstrated his use of ether as a surgical anesthesia at Massachusetts General Hospital on October 16, 1846. This discovery gained immediate recognition, which allowed for more people to experiment with anesthesia. Description of local anesthesia. So I used the website justbabyt.com, which is used as a calculator, and it would also provide a math equation for it. So I calculated by looking at the rate, uniform rate, and local anesthesia I'm using, and just plug all this information in. So for the answers, I got 1.2 call pulse for max call pulse, 1.4 call pulse for max call pulse for the second one. The third one, 0.7 call pulse for the max call pulse. The fourth one is 15.2 call pulse for max call pulse. And each of these numbers refers to local anesthesia, such as number 1 is lidocaine, number 2 is argicaine, and so on. What is a canted smile? A canted smile is where the corners of the mouth is not level, which causes one side of the mouth to appear higher than the other. Therefore, it gives the impression that the smile appears tilted or slanted. When the image to the right, pay attention to the line as it's slightly tilted. Therefore, the person has a canted smile. Problem 2, determine what I have a canted smile. To determine what I have it, I basically stood in front of a mirror and smiled. Then I used the ruler located at a horizontal position above the base of my upper teeth. If the line is tilted, there's a canted smile. Fortunately, I don't have a canted smile. The dental formula for humans and dogs. The general dental formula for both humans and dogs have the letters ICPM divided by ICPM, where basically the I stands for incisors, the C stands for canine, and P stands for premolar, and M stands for molar. So before the division sign, the part that represents the upper layer of teeth, and after the division sign represents the bottom layer of teeth. Then to find the total numbers of teeth for the top and bottom is suggested to add all the numbers and double it. So for instance, human dental formula is 2I 1C 2P 3M divided by the same number in letters. So let's add the first row together. 2 plus 1 plus 2 plus 3 equals 8 times by 216. The dental formula for dogs is basically 3I 1C 4P through 2M. Divided by is basically all the same except the last number and letter, which is replaced by 3M. The dental formula is useful as it helps dentists and people know the number and types of teeth in each species, which helps with dental health, development, and comparison between species. The sources listed below. Problem for overbite percentages. My upper teeth does not overlap my lower teeth by a far margin. Overbite occurs when the upper teeth overlap the lower teeth by 2 to 4 millimeters or more. The percentage for an overbite is more than overlap exceeds 30%, with more than 3 to 4 millimeters. This should be assigned to go to the dentist. And I got the source listed below. Problem 5. Describing the Black instruments classification formula. You see, Dr. G.B. Black developed a cavity classification system based on location and lesions. Lesions refers to any structure damage to a tooth. There's 6 classes of lesions in total, measured in terms of the locations. For instance, class 2 is located at the side surface of molars and premolars. This lesion type is a hidden decay between the teeth, primarily due to poor or no flossing. To help distinguish which denture instruments should be used for these classes, he later developed Black instrument formula based on their function, design, and blade angle. He used a 3 or 4 number system, which basically depends on the specific hand cutting instrument. And that's the source. And basically the picture on the right, that's Dr. G.V. Black. And below the class of lesions. And we basically used class 2. You can see the black dots. They basically represent the locations of what's happening. So that black dot on class 2 is basically in between the teeth, which basically happens to either poor flossing or no flossing at all. Black instrumental 3-number system. Okay, the first number is blade width in tenths of a milliliter. Second number is blade length in milliliters. Third number is blade angle from the handle. So example, alright, during a dental operation, a patient has a tooth decay on the mesosurface of a lower molar where the dentist needs to remove caries and shape the cavity for filling. The dentist uses a 3-number system for a seizure to refine the cavity walls and margin. Therefore, a 10 to 7 to 14 number is used. 10 basically contributes to 1.0 millimeters wide, which allows controlled cutting of Emmanuel. 7 allows for 7 millimeters long, giving enough reach to access deeper parts of the cavity. 14 is basically angled at 14 degrees from the handle. So looking through the picture on the right, that's a CG2 Cecil. So basically, it is kind of angled away from the handle. And the dentist basically uses the instruments along the floor of the cavity to create a smooth filling. The blade angle helps keep the cutting edge properly aligned for the Emmanuel to be removed without damaging any nearby areas. The source is listed below, and of course I have to list the source where I got the image from as well. It says it also has some important descriptions about it. Black instruments 4-number system. Basically, it's the same thing as the first to third number, except the 4 numbers there in Pokemon. So the 4-number system is used for instruments for more complex blade systems such as an angle circuit. So it adds a special 4 number. The extra number helps provide a more detailed perspective towards the dimensions and the angle of the instrument. Here's how it plays out. So of course the first to third number is the same. The 4 number is basically just the angle of the blade's curvature. It describes how much the blade is bent to curve. Example, 15 to 8 to 12 to 8. So the first 2 should be reasonable, except number 8 is the curve relative to the handle. And it shows is listed there. So to the right, you can see an angled excavator, which you can see that it's basically curved on the top. It's not curved, it's not basically like angled away from the handle, it's curved over there. That's why the special 4 number is very important. Problem 6. Mathematical model of the dental arch curvature. The formula listed in the mathematical analysis of dental arch curvature and normal calculations is y equals 3.031 for times d, which basically times x divided by w plus 1.5 to the power of 0.8, which times 1.5 minus x divided by w to the power of 0.8. The formula represents the mathematical model of the dental arch curvature. So the y represents the vertical position of a point on the dental arch curve. X is the horizontal position on the arch. W is the width of the dental arch, and D is the scaling factor called coefficient representing the curvature of the dental arch. To the right, you can see there's a graph. Over there, I used Microsoft Excel to make that graph. So on the top, it lists dental arch curvature and normal articulations. To the left is basically the vertical persistence, which is the Y, and to the bottom shows on persistence, which is the X. So on the graph, I got to research this myself too. I put the W value as 10 and D equals to 1. So since that's the average human dental arch according to pubmed.ncbi.gov. Furthermore, to find the true curvature of the graph, it also had to be negative to find a local maximum. Because the graph is indeed a positive, but XO decided to turn it negative. But that's fine. Therefore, we're going to talk about the shortcomings of the model to include the following now. So the model is kind of complicated and has a complex formula which can cause confusion among dentists. It may not accurately represent all the dental arches, such as an unusable jaw shape, and the formula may behave unpredictably on the edges of the arch and graph. This makes the curvature to be more complex. Problem 7. Basically kind of continuation of Problem 6 though. So it's basically other techniques, what is best and how it outperforms others. So other techniques the paper mentions are curve fitting, differential geometry, and finite element analysis. The paper stated that geometric modeling is the best technique for analyzing dental arch curvature as it's simple and more understood. Therefore, it ends up outperforming others. For instance, finite element analysis is more intensive, requires more specialized software and hardware, whereas geometric modeling is just pure analyzing rather just one on paper. Conclusion. The field of mathematics is very essential in the study of dentistry, as it leads to a dentist and physician William G.G. Moulton to publish his first findings of anesthesia. The dental formula for humans and other animals such as dogs, and Dr. G.V. Black, who managed to find 6 classes of lesions in the 3 and 4 number system, helped dentists know which instruments to use during the dental operation, and the formula to model curvatures of a dental arch and normal articulations, which helps analyze the position of teeth changes along the arch. These are my sources. I use a lot of sources since I basically need to find a lot of information to this project. And that's the end. Thank you for watching this amazing presentation. It really means a lot. So yeah.